Now sometimes you can be asked to find the term independent of x. Now you want to find a term in an expansion such that the number you find does not have any letter attached to it, and that is called the term independent of x. Now let's solve an example. Just like we find, the rth term or the specific term or the nth term, that's the way we are going to solve this one. Okay, so we are going to write the formula for the rth term, okay, which would be, we say it is n, choose r minus 1, okay, then you're going to get your a, you're going to say n minus r minus 1, again you're going to say b r minus 1. So this is the expression. Let's say the question they've given you, the binomial, let's say it is x plus, let's say 1 over x, let's say to the power 6. So how do you find that term that doesn't have any letter attached to it? Okay, so we're going to say the power in this case, which is our n, it is 6, so it will be 6, then r minus 1, we don't know what r is. Okay, so a in this case it is x, right? A is this, b is that, so a in this case it is x, so I can write my a, so this will be x. Now n is 6 minus r, we don't know what r is, so it is r minus 1. b we are saying it is 1 over x, so 1 over x, this is to the power r minus 1. Okay, then what do we now do? Now we can solve. We've got 6 r minus 1, then we've got x to the power 6 minus r minus 1. If I distribute that, I'm going to have 6 minus r plus 1. Okay, then 6 plus 1, that just gives me a 7. So on top I'm going to have 7 minus r, so it will be x to the power 7 minus r. Okay, then on the other side I'm multiplying this by 1 over x. Now this is just the same as this 1 of r minus 1 will fall on 1, it will also fall on x. Okay, now when it falls on 1 as a power, any number 1 to the power any number, to just be 1, right? So I'm going to write 1 over, then I'm going to have my x to the power r minus 1. Okay, now that I've got this, I can now equate what I have. Okay, I can equate this and that, okay, because they should give me the same answer. Okay, how are they giving me the same answer? Because there's a constant here which is we don't know. Okay, and because this and this should be equal, so I'm going to equate them. So therefore now I'm going to get my 7 minus r will be equals to my r minus 1. Now when I solve that, when I take the negative 1 to the other side, it becomes positive and it's going to add with a 7. I'm going to have 8. Okay, it is equals to r. When I take the r to the negative r to the other side, it becomes positive. Okay, so this will be positive r. Okay, the r and the r, they are going to add, and I'm going to have 8 is equals to r plus r, that will just give me 2r. When I divide by 2 on both sides, therefore my r in this case will be 4. So it means on number 4, that's why we're going to find the term that is not attached to any number. Okay, so on number 4, that's where we're going to find the term that is not attached to any number. So now allow me to rub this part. Okay, so now that we found r, so that's how you're going to find r in any expression that they will give you. Now that we found that it's the fourth term, okay, so our n is 6, r now it's 4. We found that it is 4 minus 1. Then we say x. Now x, it will be to the power 6. N is 6. Now we're using the binomial, expression. It will be 6 minus n minus r. In this case, our r, when you subtract 4 minus 1, it will be 3. Okay, so it will be 6 minus 3. This is multiplying by, now we have 1 over x. to the power what you are going to get from here. We said this would be the same with that. Okay, so you're going to get 4 minus 1, that is a 3. Okay, then now you solve. So you have 6, this is 3. Okay, this we've got x to the power, that is x, 6 minus 3, that is 3. Okay, this is multiplying by, we said 1 to the power anything. When this 3 goes on 1 and when this 3 goes on x, 1 to the power anything, it will just be a 1. Okay, so I'm going to write it 1 over x to the power 3. Now you're able to see that now the power of x, this is x to the power 3 and x to the power 3, they are going to divide. Therefore what you are just going to remain is 6 combination, 6 combination 3. Now 6 combination 3, we've been solving combinations, so this will be 6 factorial over 6 minus 3, that is just a 3. So I have a 3 factorial and a 3 factorial. Then when I solve what is on top, 6 factorial is just the same as 6 times 5 times 4 times 3 factorial. Everything over 3 factorial multiplied by 3 factorial. On the other hand, this one, allow me to write it as 6 because it's the same as 3 times 2 times 1, which is 6 multiplied by 6. So the 3 factorial and the 3 factorial can divide. Okay, then you have 6 and the 6 can divide as well, and they will all give you 1. Then 5 multiplied by 2, 5 multiplied by 4, that is a 20. So term number, on position number 4, that's where you're going to find a term that is not attached to any letter, and that number is 20. That's how you find the term independent of x. Let's solve another example. Let's say they've asked you to find the term independent of x of an expansion of, let's say, 1 over, let's say, 3x minus, let's say, 3x squared over 2. Let's say this is to the power 9. So how are you going to solve this one? Okay, so this is also a long one. Okay, so n is 9. You're able to see 9 is a power. So you have r minus 1. We don't know what r is, so we have to first find r. Okay. Okay. So you're going to get your first term, which is 1 over 3x. Then you said you subtract n minus, n is 9, right? R minus 1. You're going to multiply this with the second term, which is negative 3x squared over 2. This is to the power r minus 1. Okay. Now when we solve this, what are we getting? I'm going to remain with my n, r minus 1, the combination. Then when I solve what is here, this is 1 over 3x. It is to the power n minus r minus 1. Now if I distribute the negative, n minus r minus 1, it will be 9 minus r. When the negative multiplies with a positive 1, it will be positive. With a negative 1, it will be positive 1. Okay, so that this means now you can put the like terms. 9 plus 1, that is a 10 minus r. So that's what we're going to have there. So here we're going to have 10 minus r. This is multiplying by, we have our negative 3 over 2. Okay, negative 3 over 2. So what are we now going to have? Allow me to separate it. I want to put the x to be alone. Okay, so I can write it as negative 3 over 2 alone. Okay, then I can also write now the x squared. It's like they were multiplying x squared alone. Hope you've seen what I've done. It's the same thing. When I multiply back, it's going to give me this expression. Okay, my goal is for the x to be alone. Then when I do that, what do I now have? I can now put the power. The power, everything has a power of r minus 1. So I can put r minus 1 here. and also on the x squared I also put r minus 1. Now that I've got that, you know that the powers of x must be the same. Okay, so because this is the same, so this one should be the same as that one, the powers of x, because you know that this one, the 10 minus r, is also going to fall on x here. Okay, so the powers must be the same, the powers of x must be the same. So I'm going to equate them. So I'm going to say 10 minus r will be equals to 2 r minus 1. Okay, so now when I'm going to have 10 minus r, when I distribute the 2, it's going to be 2 r minus 2. Now when I solve that, when I take the negative 2 to the other side, it becomes positive, and it's going to add with the 10, and it will give me 12. Okay, now when I take the negative r, when it goes to the other side, it becomes positive r, and positive r plus the 2r on the other side is going to give me a 3r. Then when I divide by the 3 on both sides, my r therefore now will be equals to a 4. So now we are looking at term number 4. So now that we've now found the term number, allow me to rub there everything. So that's how we are going to find the rth term. Okay, you can watch videos on how to find the rth term or the specific term. Okay, we found that now the term number is 4. So now we're going to go for the fourth term using the binomial theorem. So you're going to get your power, which is 9. Because this fourth term, you know that to the fourth term we always subtract 1, right? Okay, so that is 4 minus 1, which will just give us a 3. Okay, then I'm going to have 1. The first one is 1 over 3x. This would be the power n minus r. In this case our r is 3, so it will be 9 minus 3, which will just give us a 6. Then I come to the second one, which is 1. Okay, these are multiplying, which is 1 over 3x. Okay, okay, so I'm trying to separate that 1 over 3x. Okay, actually I'm from writing. What am I writing? This is the 1 minus 1 over 3x is the one that we're just from writing. This is multiplying by negative 3. This is x squared over 2. Now the power is just going to be 3 r. Okay, according to your binomial theorem. Then n choose 3, that is 9 factorial over 9 minus 3, that is 6. So this is 6 factorial multiplied by 3 factorial. This is multiplying by 1 over 6. Now the 6 is going to fall on 1, the 6 is also going to go on 3x. Now any number, 1 to the power any number is just 1, right? So I'm going to have 1 over, then I'm going to have 3 to the power 6 and x to the power 6. Okay, now when I come to the other side, this 3 again is going to fall on all of them. Okay, so I'm going to have the 3 fall on 3. When it falls on 3 as a power, negative 3 to the power 3, you know that is just negative 27. Okay, then I have x. When the 3, there's a 3 and a 2 here, okay, on x. So x is squared, and when you multiply the powers, you're going to have 6. Okay, then this is over. When the 3 goes on 2 here, 2 to the power 3, it is 8. Okay, now that we've got this, we can solve now. Allow me to raise that. Okay, now we can solve. So you know that 9 factorial is just the same as 9 times 8 times 7 times, let me end on 6 factorial because there's a 6 factorial down. So 6 factorial and 3 factorial. Okay, 3 factorial said is just the same as 6. Allow me also to write a 6 here, multiplied by negative 27. Now, is there anything that we can do here? Okay, let me just simplify the what can I do here? Okay, so we've got 8 down here. Then we've got the x to the power 6 and x to the power 6. They are going to cancel, so allow me to cancel them in advance. Then I've got 3 to the power 6. That's the one I'm thinking about. So 3 to the power 6, just to simplify it, because this will just remain as 1 over 3 to the power 6. Allow me to write it as 3 to the power 2 multiplied by 3 to the power 4. We know that from your exponentials, when you've got such an expression, you just add in the powers, which will give me 3 to the power 6. Okay, why I'm doing that? Because I want just to simplify the work. Now that we've got everything settled out, it's just a matter of division and solving. So the 6 factorial and the 6 factorial will go. Then what other thing can we 3 squared, that is 9. Okay, it can go with the 9 here. Okay, then what other thing can we cancel? Okay, then we've got 8 and 8 can go. We remain with 6, negative 27 and 3 over 4. Now 3 squared is going to be 27, right? And when it cancels with this negative 27, I'll remain with a negative here. Here I'm going to remain with a 3. Okay, you understand, because 3 squared is 27, but now there are 4 here, so I'm going to remain with 1 3. Then what other thing can we cancel when we reach here? Okay, I think when we reach here we've got enough. 7 multiplied by the negative that is here, we're just going to have negative 7 on the numerator over, we've got a 6 multiplied by 3 down, that will just give us 18. So this will be our final answer, the term independent of x in this expansion.